Hello everyone, today we'll solve some tasks related to our given data frame, which is IMDb top 1000 movies and related statistics to these movies such as ratings. So we'll use these libraries in Python, NumPy as MP, pandas, matplotlib.pyplot as plt, we'll refer them as that, as these. So we have already downloaded .csv file as our initial data frame, and we'll refer it as IMDb. Now let's start with task one. All right. So we are required to print out columns and then rename them. Then delete poster column and show for three rows. Initially, let's start from here. Our code will start from here. Initially, it will print this, task 1 cleaning columns names and dropping poster column. Then for better display, we'll print 60 times equation sign and we'll apply clean columns function to IMDb, which is our data frame, and we'll assign it IMDb underscore clean variable. All right, now let's analyze this function. What does this function do? We follow, by the way, Google style guide. Therefore, you see these comments here. This is description of this function and arguments and return type of this function. As you see, it is return type is pandas data frame. Good. We'll um, follow try except method. Initially, we are printing this. By the way, I will try to skip this kind of things. It's because I hope these are clear for everyone. So no need to explain them. I will try to basically focus on logic of the code and some functions. What do they do? For example, here we are converting column names to list. All right, and here we define new column names. For example, poster link will be poster URL, series title will be title, release year will be year, and etc. Then, after defining them, we have to execute it, let's say. Therefore, we use rename method, rename function. And as you see, columns are assigned new columns. So it means the names, column names assigned new names, new column names like this on the right hand side. So after that, by the way, you see we have df clean variable, which is refers to our new adjusted data frame. And here we drop a column called poster URL. All right. And then we convert them to list, these names, and print it using print function. After that, we have to display for three rows. We are using pandas option context. And as you see here, display max columns and display views, both of them are known. It means we'll display them in maximum size. Therefore, we wrote here none. And diff underscore clean dot head 3, it means we'll show the initial three rows of data frame. So at the end, it returns diff clean. And for error handling, we have error messages, except exception as is. This is for general uh, error message, unexpected error. It happens, for example, when we divide by zero. All right. But when column is not found, this error will be displayed, column not found. Good. That's it for task one, and let's see the result. As you see here, original new columns after cleaning, and these three rows with new titles. Good. Now let's pass to task 2. Here it's required to show relevant statistics about the data, and we have to explain what we understand from this summary. So initially this will be executed, data and statistics, and here our argument is IMDb clean. And if you pay attention here, we mentioned what's IMDb clean. It was here. IMDb clean is this, yes. Clean columns applied on initial data frame. All right, good. Now let's continue with this data set access function. Initially, we are creating copy of this data frame to avoid modifying, losing, let's say, or original data frame. So therefore, we apply copy method function, and here we attempt to convert runtime and gross to numeric values. For that, we use uh, pandas API types is object D type, df temp runtime, and as you see here, strings are converted to data type float. All right. For gross, again, we convert it to numeric value, but initially we are removing comma sign and dollar sign. And to do that, we are using replace method to do this, and reject false. It will be patterns are fixed strings. All right. I mean, this will help us out. So then, now we know that our numeric columns will be these. All right. Rating, metascore, votes, runtime, gross. Good. Now we'll filter to only include columns that are actual numeric in dftemp, and therefore we are applying this and putting conditions that pandas API types is numeric data type, then applies this loop. All right. We are taking each of them, like rating, metascore, votes, runtime. It will loop inside this. All right. I hope it's clear. Now, what do we do? We're using describe function here, and that's to create this summary, and let's enter print it. Good. Now let's look at this in size and conditional printing based on column availability in summary. In summary columns, if rating in summary columns will print this. Ratings are high, means this, all right, showing top movies, etc. So we apply it for votes, for runtime, all right. And by the way, we have an else case here when runtime statistics is not available, all right. Good. So now let's pass to task 3. Here it's required to analyze our data and if they're missing or incorrect values, and what are they? And are there imprecise data types, string instead of integer? By the way, we didn't run the task 2. Let me run it and show the results. As you see, this is statistics, including first quantile, second and third quantile, and these are insights. For example, ratings are high, mean is 7.9, shown top movies. Votes vary greatly, as you see, max versus minimum. Runtime average is this, gross revenue shows this, all right. All right, now let's continue with task 3. You are already aware of instructions. Now let's analyze code. Initially, it will start from here. As you see, we have a new variable called IMDb clean. Then this is assigned to data quality analysis function with this with this data frame. Yes, with this argument. Now let's look at this function, data quality analysis. So the purpose of this function is to check for missing values and fix imprecise data types. Initially, we are counting missing values, as you see here. Is null will return either true or false. And we are summing truths, all right? And if it's, by the way, yes, we are summing up them, and then we'll print if missing is values is the number of missing values is bigger than zero. All right, good. Now we are creating copy of our data frame and converting strings to float data types. For gross, we are removing comma and dollar sign and convert them to float data type. And then we are we ensure integer uh, allowing for missing values. I mean, therefore, we are using PhD pandas to numeric with errors, course, and to handle non-numeric values like PG. All right. Now we fill missing values. All right. We fill missing values at the end. It will return this. Now let's see our result. Missing values are certificate, 101 times Metascore, grows, and as you see, the type is 864. So good. I hope this is also clear for all of us. Now let's continue with task 4. Generate statistics again. What new do you see? Okay, we'll start from here. Post cleaning analysis with IMDb cleaned. All right. And this function will create statistics on clean data and explain what's new here. All right. We know that our numerical columns is this rating, Metascore, votes, runtime, cross here. All right. So we'll describe them using describe method, as you see here, and we'll print it. Good. Then what do we do? Just we explain this that runtime growths here are non-numeric, can do math operations, no missing values in Metascore and certificate can calculate correlations and average properly. All right. So good. I hope it's clear too. Now let's continue with task 5. Here it's required to write a function which will return n highest rated movies of a given year, and it should accept data frame, year, and movie content and return a new data frame with top movies from IMDb. And we should be able to get movies by Metascore instead of IMDb rating. So good. We'll apply top movies by year to IMDb cleaned. Then we'll print it. And after we'll apply this. All right. Again. For example, this is just by the way for an example. You can write any values here. You can change here. All right. Here, these values can be changed. But to demonstrate it like this, I applied these numbers as you see here. Now let's look at function. The important part is this. So we'll return in highest rated movies of given year, all right? Good. We filter by year and get top n. Therefore, we are taking year parameter here, and if it's equal, we'll choose that year. Data is set here, let's say. And then, if meta score, in that case, we'll take it. Otherwise, we'll take rating. And top movies will be what? To see top movies, we use n largest function with these two arguments, n and rating column. To display results, what do? We use, um, by the way, again, if use metascore exists, it will be metascore. Otherwise, it will be IMDb rating. Rating tab will be this. And we'll print top M movies of year. And by the way, as you see here, we are looping in enumerate with two arguments, top movies, it iter rows and one parameter arguments. So that's it. It will print this table and this data as you see here. For example, for 1993, it will print top three movies of 1993 by IMDb ratings with these movies. But of top movies of 2010 will be due to Metascore. And these are all related data. So now let's continue with task 6. Print out the highest rated movie of every decade. For example, 98. Using your function above. Just we apply uh, function above, but uh, we used it inside a new function called top movies by decade. We'll find highest rated movie on of each decade. Now, what do? Again, we are creating copy of this data frame, and since it is said find decade, therefore, if you do this operation, divide by 10 and times by 10, then, by the way, we apply this um, to find, let's say, movies which are published in this, which are published in decades. For example, imagine there is a 2018 here. If we divide by 10 by hard division, let's say, integer division. It's called integer division, by the way, but sometimes I'll call it hard division. It's because we avoid from remainder. All right. So, for example, 2018 divided by 10 will be what? It will be 201. All right. And again, time by 10, it will be what? 2010. All right. Since it is required to find decades, therefore we apply this. So get top movie per decade. Again, if metascore, in that case, will rating column will be metascore. Otherwise, it will be rating. And we group by decade, as you see. All right, good. Display results again, metascore. Then use metascore. Otherwise, it's for IMDb. We print this message, and we iterate in top movies. It rows. All right, and that's it. Now let's see the result. As you see, highest rated movie per decade, top and rated movies by decade. So you can see our result. Now let's continue with task 7. All right. Write a function which will get the commercial most successful and directors. So we create a function called most successful directors with our data frame IMDb cleaned. And we'll get commercial most successful and directors using this function. Initially, we are calculating total gross revenue per director. Therefore, we are choosing this category and summing them, sorting them in descending order, and get top end directors, as you see, using head function. Then just print this message, top, for example, 10 commercial most successful directors, and enumerate will print each of them. For example, top 10 commercial most successful directors. This. All right. And this is in table format. Good. It is easy one, right? Now, task A. Write a function to find actors who starred the most amount of times in top movies. And who is at the top of the list? Now, therefore, we create a function called most frequent actors used against this IMDb clean data frame. Initially, we filter top movies. For that, since it's mentioned IMDb rating 8 or more, we are putting that rating should be 8 or more, and Metascore should be 90 or more condition. And then we combine all actor columns and count occurrences. All right. So we concatenate this star 1, star 2, star 3, star 4, and count them using counts function. Right. Then we print this message and looping in this table, let's say, and that's it, right? And top actor will be the first zeros. And by the way, indexing starting from 0, therefore we'll say zeros element of this row. So good. Now let's the result. For example, this is most start most in top movies, as you see, and top of the list is James Stewart with 5 movies, as you see. This is a table format. Good. Now let's continue with task 9. Write a function which will get the commercial most successful in actors. All right. Again, we created create this function, most successful actors function. Um, Taking two arguments, our data frame, and for example, most successful 10. We can increase it, decrease it. What do we do? Calculate average gross revenue per actor across all the movies. All right. So we're taking all stars, and what do we do? We are taking unique values using unique function, and if actor is equal in this data frame, I mean, it's the same as in these columns, star 1, star 2, star 3, star 4. In that case, we are taking the mean, summing and taking the mean, uh, and then just what do we do? Sorting them by average gross and get top n actors. All right. By the way, you see that it is in reverse, so the reverse is true. So that's it. All right. By the way, average growth will be precision in zero as a decimal point precision. I mean, it will be something like that, let's say. All right. Not something like this. It will be something like this. All right, good. Now let's see the result. As you see, Tesla Ridley, John Boyega, Michael Rodkis, etc. So good. Now let's continue with task 10. Write a function which will find the highest rated movie by a given genre. Both IMDb rating and Metascore options should exist. Add a flag which will choose among movies with only one genre. So initially we execute these functions called highest rated by genre and taking two arguments, IMDb clean and for example drama. This is just example, right? You can change these categories. For example, here we apply comedy, etc. So as you see here, we have again four arguments. We have to find highest rated movie by given genre, right? Filter by genre. If single genre, only in that case, what do we do? We're checking if genres are same, so we'll take them. All right. Otherwise, what do we do? Uh, String contains genre and by the way, a name is it is empty, which we don't consider it's empty once. So here we get highest rated. Again, uh, I'm sorry. If it's use Metascore, in that case, rating column will be Metascore. Otherwise, it will be rating. For n largest, find it. And if it's empty, we print none with this font for general, right? Good. We apply these. Perfect. I'm printing relevant data. Now let's see the result here. As you see, uh, Strangle of or How I Learned to Stop Worry movie. Year 1964 is the certificate. Perfect. Highest IMDb rating rated drama movie is this. Highest Metascore rated comedy is this. Perfect. Now, task 11. Get all the possible genres and store them in a series variable. Call the function you created and print out the top movies by every genre. So print top movies by every genre. For that, we're looping in genre series, taking genre and applying highest rated by genre function. We create it above all right here. Create it. And all genres, again, splitting them with comma, uh, taking unique values and just print them as you see. This is our result. Mhm. Now, good. Now let's continue with task 12. Write a function which will find the most common genre by a decade. What is the most common genre of 1970s or 1980s? Why? So here we'll print most common genre of 1990s. This, but as you see, we have most common genre function. Sorry, it's not function, it's array. But this array contains the results returns of this function. Most common genre by decay. Now let's analyze this function. What does this do? We are taking a copy of uh, this data frame to avoid changing original form, all right? And since it mentioned decayed, therefore we apply this. I explained what does it mean already in a previous question, so I don't want to lose time. What do we do here? We get most common genre per decade, and we group by decade and genre parameters and apply this. After, just we print in loop due to each genre. Now what's the result? As you see, 1920s action adventure comedy, 1930s comedy drama, 1940 action crime drama. You see. Now let's continue with 13th task. Find great movies which are not well known. Get movie names which have 20 votes or less, while having gettable 8 or more, make an option for Metascore. We have function called underrated great movies, taking two parameters of a data frame and use Metascore is false. It means we'll ignore use Metascore case. If use Metascore and votes is less than 20,000 and Metascore is more than 90 or equal to that. Rating type, I'm sorry, rating type will be this. Otherwise, if rating is bigger than equal to 8, rating type will be this. And we'll print it. By the way, we'll use loop in movies it rows. We'll iterate for each movie and just if Metascore if it's use Metascore movie it will we'll take Metascore one. Otherwise we'll take rating. All right. This again easy. Now this the result. This is the result. All right. Good. 25, 50. Okay, anyway. Now, 14th task. Write a function which will return a dictionary of statistics about a director. Movie title, series with years, best rated movie, worst rated movies, the average IMDb rating of movies, average Metascore, average runtime of movies, total gross revenue, genres of movies directed. So now, look at here. What do we do? Execute and display as a table. Let's start with this function called director statistics. It will return dictionary of statistics about a director. Initially, we are checking if the director name is the same with this director name. If yes, good, take some. If director moves is empty, will return none. And stats will be this. Movie titles, director movies title year, best rated, and largest, we are taking one rating, title rating, worst rated, and smallest, we are taking. For average, we are using mean functions as you see. For total gross, we are using sum. Genres, we are taking unique genres. Good. And this is for display just. This is for just display. I don't wanna mention them. It's easy one. Let's not lose our time. Otherwise, video will be too much. I don't wanna to make the video too long. So therefore, yes, this is our result. Task 4, 15. 15, 14 is completed, now 15. Write a function which should plot a histogram showing movie frequency by every year. Function should accept a range of start year and end year. So we'll execute this function, movies by year histogram. Now let's look at what does it do. I'm sorry. Uh, Plot histogram show movie frequency by year for given range. Alright, this function plot histogram show movie frequency by year for given range. Initially, we are filtering movies in the year range. Alright, so if year is bigger than start year and less than end year, we are taking those movies and keeping in filtered movies. Then we create histogram. There is a mass plot figure. For histogram, we are using histogram. As you see, each color will be black, and title will be movie frequency by year. Start year, end year will mention. X label will be year. Y label will be number of movies. So we'll using show will print it. As you see, number of movies here, year is here, movie frequency by year. For example, 2020. So it is right. Now 16th task is write a function which will accept a numpy array of director names and generate a bar chart based on the movie count of each director. Good. We'll execute with sample directors. For example, Christopher Nolan, Steven Spielberg, Martin Scorsese, Quentin Tarantino, James Cameron. We'll take this array and apply this. Good. Generate bar chart of movie counts for given directors. As you see here, this is bar chart. Initially, we are creating array, movie counts and valid directors, and looping in director names, taking each director and checking length and keep it in count. If it's bigger than zero, we append it. All right. And here, for creating bar chart, it's algorithm. Color is sky blue, edge color is black, as you see. Title is this, same X label is director, you see, number of movies is Y label. So good, perfect. I hope this is clear too. There's nothing to explain here. And task 17, the last task that we'll discover. Find and plot correlation between columns. Year-end growth, year-end runtime and growth, rating for both IMDb and Metascore, rating and runtime. So now let's look at here. So this is explanation, by the way, but I want to take your attention here. This function, plot correlations. We'll plot correlation between different columns and explain results. So initially we create subplots. As if we are using mass plots, subplots. Subtitle will be correlation analysis between movement attributes with font size 16. Good. Now, year versus growth. As you see, year versus runtime versus growth. Here we are using with precision with two decimal points. As you see, if it's growth, you are taking growth. If it's runtime, you're taking runtime for growth. Growth. So they're same. I don't want to lose time here. And we're using matplot tilot layout. All right, we use this and then show. Good. By the way, here you can see explanation regarding this tile layout. All right. Just the padding between around subplots to exclude an artist on the axis from bounding box calculations that determine subplot parameters for the artist. So good. As this is explanation, I want to read them. For first one, year versus growth, positive correlation. Movie revenues generally increase over time due to inflation and market growth. But year versus runtime, there is weak correlation. Why? It's because modern films are not longer than older ones. Runtime versus growth, again, weak correlation. Movie size doesn't predict box office success. IMDb rating versus growth, again, what correlations with critical acclaim doesn't guarantee commercial success. Metascore versus growth, weak correlation, professional critics score also don't strongly predict revenue, and rating runtime, very weak correlation. Movie quality isn't related to duration. All right. So that is it for uh, this exercise. I hope everything is clear. I tried to do my best, although I am tired, but I try to explain all this stuff. And yes, that's it. See you.